All right, well, hello everyone, and welcome to today's SANS webcast, Python Regular Expressions for the Win. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Joff, SANS instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Joff.
Thanks, Carol. So good afternoon, everybody. Happy Friday to you. It's always good to be Friday, and we've already said it's Friday the 13th, but I'm trying not to focus on that. We're going to do a webcast about Python regular expressions. And what I've decided to do today is talk about Python regular expressions with an objective in mind. One of the things a lot of us in the information security community spend a tremendous amount of time doing, especially if you're more of the blue team ilk or a forensic person, quite often you're going to want to read files and you're going to want to extract and analyze some sort of data from those files. Now with Python, this can be very easily achieved if we combine a couple of different concepts in the language. So this is not going to be necessarily a beginner's Python webcast today. I'm actually going to put together a basic tool where we can read a DNS log file. The DNS log file in question is going to be produced from bind9. Then we can extract and analyze some of the domain data from that file. And with respect to the agenda for today, how we're going to actually achieve these steps in Python, we're going to talk about regular expressions, of course. Then we're going to talk about another concept in Python, which is dictionaries. And specifically, we're going to talk about a counter dictionary. And then we're going to talk about reading the actual log file itself in Python, and then ultimately putting all these concepts together to actually build ourselves a small tool to extract and analyze domain name data from the DNS log source. So without further ado, I'm going to launch into a little bit about regular expressions. So a Python regular expression is a string that defines a pattern to match other strings. Regular expressions are highly efficient in the language, but they can be difficult to read. In fact, many people say regular expressions are a write-only language. Well, that's because they can be fairly complex when you express them in a variable inside of a script. However, they're extremely useful to extract meaningful data out of larger groups of data. And in the example we're going to use, and that is extracting data from log files. Python has a module called RE. RE is actually the module that's responsible for implementing regular expressions in the language. And to use it, we actually import that module into our script or into an interactive interpreter. For our purposes, we're going to import it into a script. Then we have a number of methods or functions of the regular expressions module, one of which is find all, that actually allows you to match the regular expression against some sort of string of data to search. Before we get into that too much, though, we need to understand a little bit about regular expressions. So not only do we have the find all method, we've got the match method, a search method, as well. Now the match method, slightly different from the find all and the search method. In the match method of Python regular expressions, we actually start at the very beginning of the string variable or the data to search for a pattern. And in the search method, we can actually match that pattern anywhere in the data or in the string variable. In the case of match or search, they actually return a special object in Python, which is actually a regular expression object, which we then have to use another method or a function, which we call group, to actually extract the data itself. Find all, on the other hand, actually allows you to perform the regular expression match against the data, and it returns for us a Python list. So find all is actually a little bit easier to use inside of the Python interactive interpreter when you're testing regular expressions, because you can see the result immediately as that list will actually show up on the screen, the Python list. In the bottom examples, you can see a couple of find all matches. What about the rules of regular expressions? Well, whenever we're using a regular expression, we actually move left to right on any one string to match that regular expression against the string. So we're going to keep using find all for a minute in these examples. Here we have re.findAll, the string SANS against the pattern, the pattern SANS against the string the SANS Python class rocks. So we have a little bit of subtle messaging here, right? Because really the sec573 class does rock, okay? Now when findAll tries to match this pattern of SANS against this string, it will give you a match for the exact string that is specified here, which is SANS. That is almost the simplest kind of regular expression that you can construct. It's basically any text in the pattern will match the actual data that you're matching against. Now, the second example here tries to match the regular expression dot Ithon against the string IPython, UPython, we all Python. Now, by doing this, the dot in a regular expression, or the period, actually means match any character, absolutely any character at all. So when we try to match that against this sentence as a string, we end up getting a list returning 3 different matches. We get Python, Python, and Python, because as we're moving left to right across this string, the dot matches any character, and then the YTHON match those characters exactly in the string that we're matching against. And so we can see that uppercase or lowercase p is going to get us a match. So that's a little bit more of a complex example. Okay. Now in the next example, we are using a match against a particular text character set. This is \w in regular expression notation. What it means is match any character that's in the set of A through Z lowercase, A through Z uppercase, 0 through 9, and the underscore. And we have specified actually 8 of these in a row. So if we match this string over here, and we are looking for exactly 8 characters that are in this set of characters in the string, we would pull out the password substring out of that data. And the reason we're pulling out only password is because the open parentheses here, the star, the ampersand, the dollar, the H, and the open parentheses, and the @ and the dollar again, all of those characters are not in this text character set. But the P is, so we match that first one, ticking that off. Then the A is, we match that second \W. The S is in that set, we match the third \W, and so on until we consume the entire pattern and match the full 8 characters in the set, yielding us the first result in the returned list. Okay, so this is kind of interesting for me, because normally I actually teach this slide to people that can ask me questions, and it's normally fairly interactive. But in this forum, we're going to sort of present it, and then we'll talk about questions later. In the third example here, and I'm not going to move through all of them, but in the third example, we are matching 2 characters, one called \W, which is anything in this set, and then the second match \uppercase W, which means anything that is not in this set. In other words, the opposite, or the negation, if you like, of this set of characters. So as we move across this string here in the second parameter, this uppercase G is in the set. This E here is not in the set. Double negative, right? Meaning we didn't get a match. The T here is in the set. The space is not in the set, and so we get a match of T and a space in the result. And then we keep consuming this string left to right until we match the entire, all the characters in that string, and we pull out each individual match associated with our regular expression. So we move left to right whenever we're matching on a regular expression string, and every string that we feed it is going to be consumed from left to right as the regular expression tries to match each portion of that string. Now, another question I often get is, what is this little r character in front of this string? A little r character in the world of regular expressions actually is more of a generalized Python concept. It actually means treat this string that's enclosed by these quotes as if it is a raw string. And what I mean by raw string is we don't want the Python string engine to reinterpret this string as if it were a regular string that we're going to perhaps print, for example. And if we want to tell Python not to reinterpret this string as if it were a printable string, then we place the little r in front of it so that Python doesn't do anything special with that string. It just passes it straight on into the find all method or function without trying to reinterpret any sub part of that string, if you like. Now, some of you are probably aware that in strings, in many programming languages, there are backslash characters that are special characters that represent things like carriage returns and line feeds and stuff like that. That's exactly what I'm talking about. We don't want this string to be reinterpreted in any special way. We want to pass this regular expression directly into the regular expression engine, directly into this find all method, so it is not treated specially by the Python string engine. So what are some of the other powers we can get with regular expressions? Well, we can match digits with a \d. We can match not digits with a \D. We can match spaces with a \S as in Sam. We can match non-spaces with a \S. We can match from the start of a string using this caret or hat symbol, and we can match to the end of the string using a dollar symbol, right? And imagine for a minute we don't want a period to mean match anything. What if we wanted to match exactly a period character? We can actually use an escape so that the regular expression will match exactly a period character. So here's another example here of another regular expression. Everybody probably remembers that great 80s hit. Well, if you've got gray in your beard like I do, or if you are X generation, for lack of better words, you probably remember that hit Jenny Two-Tone 8675309. I'm not going to sing it, okay? But I pity anybody that had that phone number in the United States when that song was released, because there was a lot of phone calls going around, I'm sure. Anyway, what if we wanted to write a regular expression to match that phone number? We could construct it with \d, which matches digits. So here we've got 3 \Ds in a row, and then we got 3 more, and then a dash, and then 4 more. Now notice here around these 3 \Ds here, we've got an open parentheses and a closed parentheses. Now an open and closed parentheses in regular expressions actually has a special meaning, but in our case, we want to match the phone number directly. So we're going to escape them using \open parenthesis and \close parenthesis so that we match in the text string exactly that open and close parenthesis. And then you can see how we're matching those 3 digits followed by 3 more and a dash and 4 more, giving us that phone number match in that regular expression. Now, I'm not going to go over the last one because that will take us a little too much time. Now, there's another special thing that we need to do with regular expressions, and that is we sometimes have the situation where we need to refine our regular expressions so they match more precisely some things that we want to match from the perspective of raising our accuracy. So in this case, we're matching a date. If we use a simple regular expression with \d /d/d/d/d/d/, etc., where the year, month, and day are all 2 digits, then we could potentially match a date that's incorrect, right? We could match 99/99/99. Well, that's not a valid date. There are not 99 days in a month. There's not 99 months in the year. There could be possibly year 99, but we still have a problem here that we have to refine. In order to refine this match in regular expressions, we can use what's called custom sets. If we use a square bracket in a regular expression, followed by some characters, and then followed by a closed square bracket, what we're actually doing is defining a custom set that enables us to match only a specific set of characters. So in this date example towards the bottom of the slide, we have defined a regular expression with two different custom sets in it. The first set matches a single character with the digits 0 or 1, but nothing else but the digits 0 or 1, followed by \d, which is just a digit, anything 0 through 9, followed by a /, then followed by digits in the range 0 through 3, just a single digit in this character set. 0 through 3, meaning we could match 0 or 1 or 2 or 3, followed by \d. So if we look at it from this perspective, and our date is formatted month, day, year, notice how we are now matching months that are 01, 02, 03, 04, and so on, all the way through potentially 19. It's still not exactly accurate, but it has sharpened the pencil and increased the accuracy significantly from just matching any digit. And the same thing is true of the day portion here. If we match 0 through 3 in front of days, we're going to match 00, 01, 03, 03, 04, all the way up to 09, and then 11, 12, 13, 14, all the way up to 20, and then 21, 23, 24, etc. When we get into the 30s, we're going to match 30, 31, 32, 33. Okay, we've gone a little bit beyond where we want to match for the days, but we're doing pretty well, right? Our date regular expression is better. Okay, let's talk about repeating characters. So what if we want to match more than one character in regular expressions? Well, we can do this by using a couple of special modifiers. We can use a plus to match one or more of the previous character. We can use a star to match 0 or more of the previous character. We can use a question mark. Google's trying to talk to me. That's fun. To match, to say that the previous character is an optional match. And then we can use these curly braces to match exactly X copies of the previous character, or match between X and Y copies, X and Y entities of the previous character, sorry. So look at the last example here. We have a very crude regular expression to match an IP address, okay? \d, curly brace, 1, 3, close curly bracket, \dot. That means match digits 1 up to 3 possible digits, then match a period or a dot, then match another set of digits, 1 up to 3 digits, then match a period, et cetera, et cetera, et cetera. And so many of you will recognize that, as you're in the industry, as being a dot-quoted IP address. Now, why I said this IP address match is a very crude match is because it could match the IP address of 999.999.999.999. Well, we all know that those numbers are beyond 8 bits, they're beyond 255, and that's actually not a valid IP address. However, this will give you a crude match against an IP, at least checking whether it's formatted correctly. Another concept that we can do in regular expressions, and I'll try not to spend too much time here because we are getting a little short on time, is to create something known as a capturing group. A capturing group allows us to match only the data inside of that capture group. And this is when we do use the special character in regular expressions of the open and close parentheses. So in this case, we're matching a URL link, and we've got the open and close parentheses around $*? What that means is match everything between these parentheses. $* is any character, 0 or more, and the question mark in this particular instance means disable greedy matching. We haven't covered that. We won't have time to cover that, but essentially what's happening here is we are trying to match a URL in a web page that has quotes delimiting each side of the URL, and then we're trying to pull out just the characters between the quotes. And then also in the regular expression, we are disabling case sensitivity using a special qualifier called $I, which means match in a case insensitive fashion. Now, when we actually perform that match and retrieve it back from the find all, that particular grouped match will appear in the first entry of the match, showing us that we've actually match that subgroup or that capture group and pulling out the data that only we are interested in. So search and match versus find all return us with an object, a special regular expression object that has a group method. Okay, the group method allows us to access portions of the match that are captured in the parentheses by specifying the number inside of this group method. So if we wanted to match IP addresses in this example, and we actually tried to look up group 2, whereby we have grouped each of the set of digits in the IP address inside of these parentheses, notice how group 2 is the second octet of the match, i.e. it is the 168 in this particular example. So that's an example of how we would use re.search or re.match versus re.findAll, and then pull out the second group that matched from the result. Final concept is capturing named groups. We can actually name those groups using a question mark P and then putting a group name inside of greater than and less than symbols, so that instead of having to use group and then a digit to pull out the match, we can actually use group and then a string, and the string should match the actual group name, and it will pull out that specific group match from the regular expression. All right, so this is all well and good, but we need just a few more concepts to actually cover the use case that I'm going to talk about in the sample code. First of all, I want to talk about dictionaries. Everybody's going to remember their regular expressions now, right? I know it's a lot of work. Now we're going to talk about dictionaries briefly. So what are dictionaries? Well, with dictionaries in Python, we actually have keys that become an indexed into some sort of data value. For those who have ever used Perl, they're very, very similar to associative arrays. Basically, you can insert data into a dictionary in Python, specifying a key and then setting the value into the object that's going to be retrieved whenever you try to look up that key. What do I mean by that? Well, let's have a quick look at an example here. Here we have created a dictionary in Python. It's got two curly braces indicating to Python that we are initializing a variable with an empty dictionary. Now we actually set key value pairs into the dictionary using square brackets and then the string Python object as the key, and setting it equal to the value that we want to put into that entry. So this is D, key of A equals alpha, D, the key of B equals Bravo, D, the key of C equals Charlie, and so on, right? Now, when we want to fetch a key out of the dictionary, we can fetch it by that string value directly. So D, the character string value of A, will return for us alpha because the value associated with that key in the dictionary is in fact the string alpha. Now, a special part about dictionaries here is sometimes you try to access a key that doesn't exist in the dictionary, and when you try to do that in Python, Python will often return a traceback error indicating that the key is not found. It's actually a key error specifically in the exception that is thrown. We can get around that by using a special method called get. If we use get and the key we're trying to fetch, it will also return the value associated with that key in the dictionary. However, if we try to use get with a key that does not exist in the dictionary, instead of crashing, instead of giving us a traceback error, Python actually just returns a null object. So it doesn't crash. It's an alternative way to deal with the logic in our Python script when we might not want to write a try except block, or we might not want to write some sort of special code to handle the crashing part, to handle the traceback error, if you like. Now, there's a special kind of dictionary that is very, very useful in the example that I'm going to show you in a minute. I am leading to something, believe it or not. So this is called a counter dictionary. Counter dictionaries in Python are special dictionaries that actually count the instances of keys that get inserted into the Python dictionary. How does this actually work? Well, this example is a really good way to look at it. From collections import counter, the counter dictionaries are actually imported in a special module in Python called collections. Then we initialize the counter dictionary by setting some sort of variable equal to the method call counter with uppercase C in front of it. This is the same method that we imported from the collections module. Then we can update the key count in the counter dictionary using another special method called update. Now, update takes as its argument a Python list. If you specify this list of words into the update method, what actually happens is the counter dictionary will count the frequency of every word that's in that list. Now, this long piece of Python here is actually just opening a file, reading the full contents of the file, making them lowercase, and then splitting the full contents of that file based on space and returning back a list. That list is what we then feed into the update method to give us the frequency counts. Now we can call another method in Python's counter dictionary object called most_common, and it returns for us a list of tuples in Python that gives us the most common frequency count of the words that are keys inside that dictionary. Thus, we can actually get ourselves the most frequently occurring words. So a counter dictionary is extraordinarily useful to count any kind of instance of any data that we put into a Python list. So we're counting these words. We're getting the as the key in this tuple has 5,840 instances that were in this particular file. The word to has 3,376 instances, and so on in the returned results. Now we can further update the counter dictionary by passing in another list like was is, was am as a list of strings here, and we would then update the count of those particular keys by the number of instances of those words in this list. So in this case, there is 2 instances of the word was. Over here, we looked at the key for was and we saw 491 instances of was. When we updated that count with this list, notice how the retrieving that key again shows us 493 instances of the word was. Similarly, we can subtract from the count by actually passing in a list, and it will subtract however many instances of those individual string words in that list are in the counter dictionary, and we'll come back to 491 for the key of was. So counter dictionaries are extremely useful, well, for counting things. Final concept before we get to the actual meat of what I want to talk about. The final concept is some basic file operations, which we saw just a minute ago. In Python, we can open a file using a built-in function called open. The normal way we do this is we create a file handle, we set it equal to the result of opening the file itself. The first argument to the open built-in function has to be a string with the complete file path name. And the second argument is normally a mode string. The modes that you can open with are things like read-only mode, write-only mode, append mode, read text and interpret Unicode strings, and the carriage returns as end of line, which is the default read mode, read binary and don't interpret any end of line markers, and so forth, right? Now we have a second way to open a file where we can use with open, but I'm not really going to talk about that. We're just going to focus on this first method. Once we open a file, we can actually, let's imagine for a minute, for the purposes of our particular thing that we're going to develop in just a moment, let's imagine the file is text. So we open that file in read mode, which by default opens it in text read mode. And then we can use a Python loop to loop through the file data one line at a time. And then we could potentially print those lines, for example, using the Python print function. If we wanted to read a log file, let's say it's a DNS log file, which is what we're going for in just a minute, we probably would use a Python snippet of code that's very, very similar to this. We would open the file, creating a file handle, then we would loop through each line in the file, and then we would probably want to do something with each of those lines in the file. And what we're going to do in a moment is actually match a regular expression against each of the lines in the file. Now, there's a couple of other methods with file handles that you can use. One is called read lines, where you would read all of the lines of the file into a Python list. And another one is called just .read. The .read method reads the entire file into a single string, which you can then manipulate in any which way you want to. In the case of log files, however, you probably want to use an example that's much closer to this first one. And the reason you probably want to do that is that log files are often very, very large. You might have multiple hundreds of megabytes in a log file. And if you have multiple hundreds of megabytes in a log file and you implement a Python script and try to open all of the content of that file and read it in all at once using something like read lines or read, you may well run out of RAM in your system and send your particular operating system into a slow paging, swapping death as it crashes trying to allocate all that memory, versus reading one line at a time in a file where you're only allocating enough memory for that single text line as you're reading through the log file. Okay, take a breath, everybody. Let's put this all together in a small example of a program where we are going to open a file, we're going to read lines in that file, and we're going to count specific instances of domains in that file to perform some domain name analysis. The pseudocode for our script that we want to follow is basically like this. The first thing we want to do is create a counter dictionary, which we've just discussed. And the counter dictionary is what we're going to use to count the frequencies of things in the log file that we're going to open. The second thing we want to do in our pseudocode is open the log file itself. Now, I don't think I explained what pseudocode is exactly, but pseudocode is another way of saying this is an outline of the steps in a script or a program. This is an outline of the algorithm we're going to use to perform the processing task we're interested in. Now, for each line in the file, in the third step here, we want to perform a regular expression match, extracting the data of interest out of that one line in the file. And if we are successful in matching that particular data, then we want to update the counter dictionary with the instances of the string that we're interested in. And then after doing that, we want to continue looping for every single line in that file until we finish. And then we want to print some results for ourselves. In this case, we're going to print the 10 most common results from the counter dictionary. And you saw earlier that to print 10 most common results in a counter dictionary, we have a concept known as the most_common method of a counter dictionary. So the approach we're going to take first is to develop and test a regular expression to match the particular data that we're interested in. After we develop and test the regular expression, we're going to paste that regular expression into our source code to actually try to use it to match the data of interest. We can also match and test this regular expression with a nice web page called pythex.org, which is very, very useful when we're actually testing and developing with regular expressions to get them right before trying it actually in some code or inside of a script. The second step we're going to do is write the file handling code itself. Finally, we're going to write some summary statistics code, i.e. the most common information that we're interested in. And then we're going to test our code. And if we get it wrong, we're going to rinse, lather, and repeat the process until we get it right. So demo gods, please don't fail me now. We are going to actually try to do this together here on this webcast. Yes, you heard it now, really, truly, here on Friday, the 13th of April. So here we go. All right, first of all, I'm going to go over to Pythex. And here in Pythex, we have an opportunity to enter a regular expression at the top of the page. And then we have an opportunity to pass in a test string in the middle of the page, which our regular expression will match against. And by using this, we can actually see the match result and see any capturing groups in the match result that we want to actually test our regular expression against. So let's take a terminal window here. Yes, this is a terminal window. And in this terminal window, I have dns.log. Okay. DNS.log in this case is what you might expect. It is a bind9 DNS log with the domain query information in it. In particular, we have date stamps, we have a client IP address, a client source port, we have the actual domain name that was queried, and then we have the actual query name itself and type. It's an internet query, type A. And then we have the DNS server, which the query was actually performed against. So in order to test regular expressions, what we probably want to do is just take a few lines of this log file and copy and paste them into pythex.org over here as our test string. So what I did was I took 3 lines of the file, I copied and pasted them over into pythex.org, and now I'm going to try to construct a regular expression. So I'm going to try to zoom in on 3 different pieces of data here at least. One is going to be the timestamp, the other one is going to be the client IP address, and then the third piece of data that I'm interested in is the actual domain name that was queried. Okay, and we want to construct a regular expression with grouped matches that pull out those 3 pieces of data from the result. All right, here we go. Everybody holding their breath, and while they watch that I got email from somebody. Sorry about that. Okay, let's try to develop a regular expression to match this timestamp. We'll start with \d and 2 of them, which is 2 digits. Okay, and what else? We want to match that at the beginning of the string. And what else? Is there any spaces there? No matches. Okay, we failed. Oh, guess what? I used a /, not a backslash. So now this is live regular expression truly in a demo, right? So if I'm stuttering, it's because I'm trying to type and talk at the same time, which is awfully difficult. Okay, so we match 2 digits at the beginning of this stuff, and it shows up in green. Now we want to match a dash. Now we want to match the actual month, which is 3 word characters. So let's use \w and 3. Right? Notice how our match is being updated here. Now we want to match a dash, and now we want to match the year part of the date, which is going to be \d4. Okay. Notice how now I'm matching all of the timestamp, but I'm excluding the actual hours, minutes, and seconds. So I need to accommodate those. I need a space. Okay, I need \d 2 of those. I need a colon, and I need \d 2 of those. And can everybody see that it's updating? And I need another colon, and I need \d 2 of those. Okay. Now I'm matching the date part of the string, and I'm matching the time part of the string. Now I've got a dot, and I've got my microseconds here. So we want to take those into account. The dot normally in a regular expression means match any character. So let's use \dot to match this dot exactly rather than matching any one character. And then \d3 to get the 3 digits of that microsecond portion of the timestamp. So now I've matched the exact date string, okay, the date and time string, but I haven't captured it in a group. Notice over here, Pythex tells you the captured groups that you have. All right, well, if I haven't captured it in a group, I can use parentheses around the match to actually put it into a group like this. Notice how the match 1 now gets updated with parentheses around the group. Now, regular expressions are actually line oriented in Python. A regular expression is going to match all the way to the end of 1 line. We actually want to do a multi-line match in this case, potentially, dependent on how we process the file. If we're processing the file 1 line at a time, then a multi-line match is actually not necessary. So let's stay focused on just matching the stuff that we're interested in. All right, so now we have the word client, and then we have an IP address. So I'm not going to drag this out ad nauseum, but let's just say we put space and the word client, and then a space, and we want to match our IP address. We're going to use a crude IP address match using \d1,3 and repeating that 4 times, taking the trailing dot off the end. Now notice how the regular expression matching screen here in Pythex has updated over here in green that I've matched an IP address, but we don't have a matching group there yet because we haven't captured that IP address match. If we want to capture that IP address match, we can put that in parentheses to give us now 2 matches. One is the captured IP address match, timestamp address match, and the second match is the captured IP address match. And so now we're slowly working our way towards something that's, well, potentially interesting from the perspective of our program. Now let's say we want to match the query. In particular, we want to capture the domain name that is queried. But we've got some stuff on this line between us and the beginning of that domain name that we need to kind of get out of the way. A couple of ways we could handle this. We could just try typing space query : right? But that's not going to match. In fact, our regular expression completely failed, right? Why? Because the end of the IP address has more stuff in it between the digits and the space query. One way we can get around that, we could do + space query. Now we see we're matching, right? Okay, but now we have to actually capture the domain name. So we put another space in, and then we want to capture in group, and we want to capture +, probably. Oh, wait a minute, Joff. ++ is too much. Notice how we've captured everything to the end of the line in the group match. We don't want to do that. We want to get rid of the in, a, plus, and all that stuff because we're not interested in that. Well, how can we do that? We can actually accommodate that by putting something like in space at the end of the match, which delimits the fact that the domain stands alone, and we end up with the domain match. Okay, so now hopefully everybody can see how we have slowly built out the regular expression to extract the time date stamp, the actual IP address the client query was coming from, and the actual domain name that was queried. And we can take that even further to even match the TCP port, maybe match the actual DNS server itself, maybe match the query type, any which direction that we want. Now, something else we might want to do here, though, is name our group matches. We can name a group match using the $P, and then between after the $P, you can put less than and greater than and some text in between it, thus naming the group that you're matching. And notice how this updated, showing me a named match with IP in it. We can also do that for the, well, I shouldn't have called it IP, should I? I should have called it timestamp. We can do that for the IP address now. Where's the IP address, right? Live demos. Don't you love live demos? Let's see, IP address. Here it is. And we can do $P bracket IP close, less than, and we get the IP address named. Okay, hopefully everybody's getting the idea now. And we'll try to now show you in the actual program. I've got a program called prototype.py where I have defined this same regular expression as a Python variable here at the top of the program. Okay, here we have our timestamp. Here we have our client IP. I've just called it client in the group match. Here we have our domain that was queried. Here we have the query type that was used. And here we have the server that was actually queried. So I've got more than 3 items of data. I've got actually timestamp, client, domain, and server, and query type. I've actually got 5 different named matches inside of this particular program. Now let's fill out the rest of the details. So we want to open a file called DNS log. Then we want to set a couple of variables for ourselves for housekeeping. These are the matches and the failed matches. I'm just going to count them, okay? Now I'm going to loop through every line in that log file, and I'm going to try to match that regular expression against the line of the log file that I'm currently reading. That regular expression is the regular expression that I defined in the string up here, which is called REXP, which is the full regular expression to match my log data, okay? Now, if the match succeeds, we will return a regular expression object. If that's the case, we can then update our counter dictionary with the domain data that we're interested in counting. We want to count the different domains that are in this log file, and we can go ahead and add one to our matched count. Else, we want to add one to our failed to match count, which is down here. So the logic for this program, after using this regular expression to match, is remarkably simple. We are really just looping through a file, performing a single regular expression match, and updating our counter dictionary if we actually succeeded in performing that regular expression match. Now, at the bottom of the program, we have a little debugging here, by the way. Here, I could actually print out each one of the regular expression matches that occurred, just so that we can see that our regular expression is working correctly. I've commented out that debugging because, well, I know that it is working correctly. So the final part of our program is some print statements to show the number of matches that occurred, the number of failures that occurred, and then we are looping through our counter dictionary for the 10 most common matches, and we're printing out the the domain that was matched and the actual count. And that is as much of the logic that is in this script. So the script is literally 46 lines long, and out of that 46 lines, a dozen of them are actually commented out debugging lines. So a very, very short script here called prototype.py. So now for the moment of truth, if we run prototype.py in Python, we can run it like this, Python 3 prototype.py. Now notice I'm using Python 3. I deliberately wrote this script in Python 3 and run it, and it will read through that entire domain name log, the dns.log, and nicely print us out a count of each domain that was in that log and queried, and notice how we get 6,071 for ping3.teamzero.com and so on. So we get a fantastic frequency count of all the domains that are actually queried inside that log. So this is actually a really good and fast way. If we look at the number of lines in the log, let's have a look real quick. There are 100,000 lines in that log. Notice how quick that program ran. Okay, seconds, and we have performed a frequency count of all those 100,000 log lines. So it's a very efficient way for us to perform analysis of logs using these concepts of both regular expressions and a counter dictionary, and then just some relatively simple code to print that stuff out. Okay. What if we want to improve the script? Well, we could accept a specific log file name from the command line using argparse. We could accept a directory path name and read all the log files in that directory. We might want to match a specific client IP address and only perform statistics for that. We might want to match a specific domain for statistics. We might want to match a specific DNS query type, and so on, right? We might want to refine our code and look at things in a little bit of a more refined fashion. Well, guess what, everybody? I have tried to do you a huge favor, and I've actually written a program here, which is at this bit.ly link called DNS logstat. It's actually not really called that, but the link is called that. And if you click on that and you jump over to your browser, you will go to a Bitbucket repo that is a program called BindLogstat, which I've written for you. And BindLogstat, if you look at the source code, is a much more comprehensive object-oriented version of this program to give you detailed statistics from a bind9 logstat analysis which includes matching query types, matching client IPs, matching domain names, and so forth. So you are absolutely welcome to go grab that and look at it for yourself. Now, it wouldn't be regular expressions if I didn't put an xkcd comic up. This one is one of my favorite ones, right? If you're having Perl problems, I feel bad for you, son. I got 99 problems, so I used regular expressions, and now I have 100 problems, right? I hope that after this webcast, you don't feel so much that way, perhaps a little less daunted about regular expressions, or maybe not. It's up to you. But at that point, I am going to stop. If you want to ask a few questions, feel free. If you want to learn more, I would love it if you come check out Sec 573, which is the Automating Information Security with Python class. And you will notice on my webpage that I am teaching this class for SANS another 4 times this year at public events. We have Berlin, Germany, Virginia Beach, London, and Stockholm, Sweden coming up. If you guys are stateside and want to join me at Virginia Beach, I would love to see you. All right, Jason, questions, comments, and fun stuff.
Hey, Joff, while we wait for any questions to come in, currently we don't have any, but this is a good time for people to write them if they have them. Joff, can you give me an instance in, let's say, in the last week or so where you've used Python to help you solve a problem at work that maybe could jog some of the people who are not using it yet?
Absolutely. In fact, I was just writing one today. We wanted a belt and suspenders program for a problem that recently came to our attention. And that program, I won't mention the specifics because I cannot, but the program that I wanted to develop was to generate for me an IP tables configuration that will drop IP addresses from a CIDR-based list that I just simply fed into the program, and it would automatically go ahead and generate the full IP tables configuration. And in addition, it would use the IP sets, which allows you to create actual data structures in the kernel that feed sets into IP tables to perform the IP address matches and drop the traffic. So I used Python to read the file that the user was interested in, to then go ahead and use operating system commands directly out of Python to create the different IP tables statements and the different IP sets that needed to be matched in that rule set. So that's just one example I was working on, well, literally half an hour before the webcast.
Awesome, thanks. So if anyone has any questions, feel free to ask. Looks like we're about to get one. I had one more question. With the course, you know, some people that take that may not have many Python or very limited Python skills. Are they going to do well in that class with people who have more advanced or intermediate Python skills? Is there a way in that class for everyone to have a way of learning?
There is. I'm glad you asked, Jason. The class is built to address basically 3 different audiences. It will absolutely address the beginner that's never had any coding experiences before. It will address students that have coding experience in perhaps other scripting languages and they want to sort of port their skills over to Python. And it will also address the audience of students that are more veteran coders, the more advanced, that actually have lots of skills and they want to come and learn more about Python as it applies to information security, or they want to solidify their Python understanding. The course has got a great game in it that we play all week. We call it Pi Wars, which actually helps address those 3 problems for all those 3 audiences. And also, the first 2 days of the course are a full Core Essentials workshop that will bring the students up to speed if you've never before seen Python. So it really does address all possible audiences.
Oh, thanks, Joff. Yeah, I do have a question from Joel. What Python environment do you use to develop in? Debugging has always been a problem for me with Python.
Great question. So with respect to debugging, there's a couple of things here that you should bear in mind. One is you can always use the interactive interpreter in Python to perform debugging. So there's no reason why you cannot get into either Python 2, which is default Python. It's on my Mac system right now, but you can do that with a Linux system, wherever your interpreter is installed. And you'll notice here that we pulled up Python 2713, and we can actually perform debugging statements here. We can look at that object. We can look at the type of that object. We can look at attributes of that object. So the interactive interpreter offers a lot in terms of debugging directly inside of the Python environment. And that's what I would use most often. Now, if your focus is to be on Python 3, then you would want to do your debugging inside of Python 3 directly instead, which you should normally use the command Python 3 on most Linux Unix systems. We'll bring up the Python 3 interpreter and then proceed in the same way to maybe create some variables, look at those objects, do something with those objects such as encoding and decoding and whatever suits your fancy, right? Whoops, that didn't work. Okay, demo fail. So that I highly recommend. And in fact, honestly, that is the way I do it most of the time. If you want, you do have a special module in Python called the PDB module, which is called the Python Debugger. And we can actually start a script out in the Python debugger and try to debug it. I just did it incorrectly because I used Python instead of Python 3. Okay. And that actually takes you into a debugging environment, allows you to do things like set breakpoints and then step through line at a time, and the breakpoint is met, and then you can actually debug things by printing the value of expressions and so forth. So these are the kinds of things you can do in the debugger. Whoops, I have lost my echo back. Anyway, I'm not going to try to do that live. As you can see, it can be a bit messy.
So for Joel, who asked the question, if you're watching this on YouTube, we have a Python debugging webcast given by Mark Baggett. And so that's available for anyone to watch. And I dropped the link to Joel, but for you listening to the recording, just go to our YouTube page and you can find it there.
Excellent. I just another comment there, Jason.
Oh, go ahead.
I also highly recommend the good old-fashioned print statements. You know, for this prototype logging example, for an example of debugging, put a print statement in there. And so when you're running the script next time, you can always look at that loop, and my print statement in this case printed out all the records of every log entry in that log file, and I can see that my match is correct, right? Nothing wrong with putting print statements in your scripts.
Joff, we have another question. What is your preferred Python editor? From Abdul.
My preferred Python editor, frankly, is VI, straight up with, well, I should say Vim, right? VI improved, and there are a number of modules which are useful there. I can't think of the module names right now because I put them in my Vim RC and then I walk away. But there's a number of syntax modules in Vim that work. One of the things that's most important with Python when you're editing is to ensure that your tabs are always converted to spaces and that only 4 spaces are inserted for each level of indentation, right? So if we look at this script again, in my loop, for example, if I want to insert a new statement, when I hit tab here, it actually inserted exactly 4 spaces for indentation. And that's actually very important because Python code blocks require indentation, and 4 spaces is the Python enhancement proposal standard for indentation, PEP 8 in particular, Python enhancement proposals standard number 8. All right. I need to get less verbose in my answers. Any other questions?
No, that's fantastic. That is all the time we have today. Joff, do you have any final words?
Other than learn Python, if you're in the information security industry, which I expect most of you are, one of the most wonderful things that will happen to you after you learn Python is the ability to start using your security defense tools, and in particular, use the APIs of those tools and start gluing data together by querying the APIs of a tool such as a SIM or some other log analysis tool and being able to spit that data back out, maybe insert it into another database. This is the kind of thing that Python is extremely useful for, and you will not regret learning it as part of your career.
Thank you, Joff. Back to you, Carol.
All right, well, thank you so much, Joff, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.